Here we are having some trigonometric formulas which we'll be using for solving some of the questions. So these are the three basic formulas: sine squared x plus cos squared x equal 1 plus tan squared x equals sec squared x, and 1 plus cot squared x equal cosec squared x. So these are the basic formulas. Apart from that, instead of that, we are also having these kind of formulas. Sine of 2x, it will be equal to 2 tan x by 1 plus tan squared x. Otherwise it can be also written in this form: 2 sin x cos x. And for cos to x, we have this formula: 1 minus tan squared x by 1 plus tan squared x. And we are having many other formulas also. I didn't mention many of them. Then tan to x is also there. We have this formula: 2 tan x by 1 minus tan squared x. Then for sin 3x, we have this formula: 3 sin x minus 4 sin cubed x. This is cubed, it should be equal to sin 3x. Here we are having 3 times x. X is a variable, and here we are having 2 times x, like that. So for cos 3x, it will be equal to 4 cos cubed x minus 3 cos x. And here finally for tan 3x, we have this formula: 3 tan x minus tan cubed x by 1 minus 3 tan squared x. For cos to x, we have 3 other formulas also apart from this one. In terms of tan, we have this formula: cos squared x minus sin squared x. So instead of sin squared x and cos squared x, you can shift terms using this formula: cos squared x plus sin squared x is equal to 1. So when you substitute, instead of cos squared x as 1 minus sin squared x, we'll get this formula. And instead of sin, if you're substituting it as 1 minus cos squared x, you'll get this formula. So there are 4 different formulas for cos to x, and we may need to use them in certain conditions. So we are having one question here, and we have to use some identities to solve this kind of questions. So first question is: y is equal to tan inverse of 3x minus x cubed by 1 minus 3x squared. So when you check at the angle inside, at the value inside, it is similar to this formula. If you see, you have to know the formulas, then only you can solve these kind of questions. So tan 3x, it is equal to 3 tan x. Instead of x, we are having tan x. Instead of x cubed, tan cube x. And instead of x squared, tan squared x. So it is similar to the same part like this one, same formula like this one. So what we can do means, instead of x here, we are having tan x. But here the variables cannot be same, right? So instead of x, we can put it as tan theta. So x, it should be equal to tan theta. So this is our condition which we are setting: x equal tan theta. So when we are taking the derivative of d by dx by dx, what we can do means, first we'll be writing theta in terms of x. So it will become tan inverse of x, right? Tan goes to the other side, it becomes tan inverse of x. When we are taking d theta by dx, it will be equal to 1 by 1 plus x squared. This is the derivative of tan inverse x formula: 1 by 1 plus x squared. So the derivative of theta will be equal to the same formula. So first of all, instead of x, we'll be trying to substitute tan inverse of 3. Instead of x, it should be tan theta. So tan theta, 3 tan theta. So tan cube theta by 1 minus 3 tan squared theta. So you can simplify this to this equation form. So it becomes tan inverse of, this equation will be equal to, instead of tan 3x, here we are having, instead of x, theta. So it will be tan 3 theta, right? Instead of x, we have theta here. So tan and tan inverse gets cancelled, so it will be equal to 3 theta. So y is equal to 3 theta, and we have to find out dy by dx. So 3 is a constant, so you can take it before the derivative symbol. So d by dx of theta. but we don't know what is d theta by dx. So what we can do means using this part of the question, like what we assumed, we found out d theta by dx already, right? So this one d theta by dx, it can be replaced by this derivative which we found out already. So it will be 3 multiplied with 1 by 1 plus x squared. So it will be 3 by 1 plus x squared, because here it will be 3 into 1, right? So it will be 3 in the numerator divided by 1 plus x squared. So this is the final answer for the derivative of y, 3 by 1 plus x squared. So we are having another question here, and we have to find out dy by dx here also. So if you check the outside, we are having sine inverse of x. So whatever is in the inside, we have to try to make it as sine. So the sine inverse and the sine would get cancelled. So for sine, we are having this formula, sine of 2x, it will be equal to 2 sine x cos x. So we can try to apply this formula here also. Instead of x, if it is sine x, and instead of 1 minus x squared the whole root, we will try to make it as cos x. So what we can do means, we can do the substitution here. Instead of x, we'll try to put it as sine theta. We'll give another variable here. It cannot be x on both sides, right? So x equals sine theta. So when we are writing theta in terms of x, it will be sine inverse of x. So when you are taking the derivative, it becomes d theta by dx equal, this is the formula for sine inverse of x, right? 1 by root of 1 minus x squared. So this is the d theta by dx here. So now let's try to substitute all the x by sine theta. So it will be y is equal to sine inverse of 2 sine theta, then root of 1 minus sine square theta, the whole root. Now here we have to apply another identity here. So it will be sine square theta plus cos square theta equal 1. So when we are taking the sine square theta to the other side, it becomes cos square theta equals 1 minus sine squared goes to the other side, it becomes negative, and a sine square theta, right? So if you check this part, 1 minus sine square theta and what's inside the square root, both are same. So what we can do means, we can substitute instead of this one as cos square theta. So it becomes sine inverse 2 sine square root cos squared. So this square and the square root both will cancel each other out. So it becomes y is equal to sine inverse 2 sine cos. So according to this formula, when we are having 2 sine cos, we can write it as sine of 2 of the same variable. So it will be equal to sine inverse, instead of this one, we can write it as sine of 2 theta. The variable doubles as this is the formula. So here sine and sine inverse will get cancelled. So y is equal to 2 theta. Now we would, what we need is dy by dx. So when we take the derivative, so it will be 2 times d theta by dx. So derivative of theta only we need. 2 is a constant, so we can write it before the derivative. So d theta by dx, we already found out here, it is equal to 1 by root of 1 minus x squared. So what we can do means, instead of d theta by dx, we can substitute this one, and it will be equal to 2 by root of 1 minus x squared. So this is the final answer for dy by dx.